Welcome to the online video lecture series for college algebra. This is chapter 10, in which we are going to be covering conic sections. I'm Dr. Scott Franklin, and I'll be walking you through these lectures. In chapter 10, we introduce a new mathematical object, basically a set of equations that are known as conic sections. Now we're going to come back in the second section of this chapter and give you an example of why these functions are called what they're called. But really what they are is a generalization of the parabolas that we covered in chapter 8. When we learned about quadratic equations, we learned about equations that had graphs that were shapes like parabolas. Well, we're going to generalize that idea by allowing not only the x variable to be squared in the equation, but also the y variable. And so what happens whenever we do that will take us some places that we can actually have some applications where those types of equations show up. To begin with, in section 10.1, we're going to start by looking at the distance and the midpoint formulas and then use those to derive the equations for circles. Let's start by talking about the distance formula. So let's consider 2 points in the plane. So let's take our rectangular coordinate system, and let's say that my first point is right here. Okay, that would be x1, y1. And let's say my second point is somewhere up here, and we're calling that x2 with a height of y2. Our question is, what is the distance, the straight line distance between those 2 points? Now, in order to answer that question, we go back to a well-known mathematical theorem called the Pythagorean theorem. In fact, it's one of the most well-known of all mathematical theorems, which in equation form says a squared plus b squared is equal to c squared, where a, b, and c are the sides of a right triangle and c is the hypotenuse. So if you take any right triangle, meaning that one of the 3 interior angles is a right angle, labeling the sides A and B and the hypotenuse C, we always have for any right triangle that a squared plus b squared is equal to c squared. Alright, and if you look closely up here, we can actually turn this drawing into a right triangle by taking a straight line from this point parallel to the x-axis all the way over to x2, and then a straight line all the way down from y2 down to y1. And that forms a right angle. Now, since that's a right triangle, then it satisfies the Pythagorean theorem. So all I need to know is how long each side is, and I can plug that into my Pythagorean theorem. Now, clearly, since this distance, that is the distance from the origin all the way out to x2, is x2, and this distance is x1, then the distance in between x2 and x1 would be x2 minus x1. That's this distance here. Similarly, the length of this side of the triangle would be a height of y2 minus y1. So if I let x2 minus x1 be a, I let y2 minus y1 be the b, and clearly the distance that I'm trying to find, the d here, is the c, then just plug those in. And if I plug them in, c squared is d squared, a squared is x2 minus x1 squared, and b squared is y2 minus y1 squared. Okay? That right there comes straight from the Pythagorean theorem. Now, because distance is always positive, I'm just going to take the square root of both sides, and I end up with d is the square root, and again, because distance is positive, I'm not going to put the plus or minus out there. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. This is the distance formula. It finds the distance between any 2 points. We can now use the distance formula to find the distance between a given pair of points. we do not need to draw the picture because all we have to do is plug into the formula. What we do need to do is label each point as the first or second. It doesn't matter which one is the first point, which one's the second point, but as long as we label them x1, y1, and x2, y2, we can now plug in to the distance formula that d is x2 minus x1 squared plus y2 minus y1 squared, a formula you should know. Okay? So d is the square root x2, which is negative 5, minus x1, which is 3, squared, plus 12 minus 6, quantity squared. Now we do our order of operations, so we simplify inside the parentheses. It gives us a negative 8 squared plus 6 squared. So that becomes the square root of 64 plus 36, which is 100. The square root of 100 is 10. So the distance between those 2 points is 10 units. Let's do another one. Call this x1, call this y1, call this x2, and y2. So distance would be the square root of negative 1 minus 2 squared, that's x2 minus x1, plus 4 minus 1, quantity squared. That gives me negative 3 squared plus 3 squared, which would be the square root of 9 plus 9, or the square root of 18. And having covered in Chapter 7 how to simplify radicals, we can't leave our answer this form. We need to split it and have it as a simplified radical. 9 times 2 is 18. Square root of both of those gives me 3 square roots of 2. Now, the midpoint formula is a formula for finding the halfway point between any two given points. So if you have on your plane 2 points, much like we did before where we were finding the distance between them, say this is x1, y1, and here's another point, call it x2, y2. On the line in between there, we want to find the point that's halfway in between. Right? We want to find this halfway point. And so what we really need to do is find the halfway point between the x's and the halfway point between the y's. And that would give us the point that's halfway in between the two original points in the Cartesian plane. Well, the way that you find a point that's halfway in between the two given points is to average the x-coordinates and the y-coordinates. Now, you know what average means is to add the numbers together and divide by the number that you have. So if I want to find halfway between x1 and x2, I would add them together and divide by 2. If I wanted to find halfway between y2 and y1, I'd add them together and divide by 2, which is exactly where this formula comes from. The x-coordinate for the midpoint is x1 plus x2 divided by 2, and the y is y1 plus y2 divided by 2. So simply, to find the midpoint of the line segment between the point 1, 2 and 7, 3, I would again label them as x1, x2, y1, nope, sorry, I said that wrong, x1, y1, and x2, y2, and average the x's and average the y. So the midpoint would be x1, which is 1, plus x2, which is 7, divided by 2. And the y-coordinate would be y1, which is 2, plus a negative 3, divided by 2. Always divide by 2 because that's how many points we have. Right? So we end up with 8 over 2 and negative 1 over 2, or 4 comma negative 1/2. That's the coordinates of the point that is the midpoint of the line segment between these two. And that's it. Now let's talk about circles. Now the formal definition of a circle is the set of all points in the plane that are some distance fixed distance from a point called the center. So if we were to let the center of a circle, say, be the coordinates hk and the radius is r, then according to our distance formula, we would say that the distance from any point, which we'll let the coordinates be the variables, x comma y, right? Let those be all the points that are on the circle. So what we're saying is the distance from any point on the circle to the center is r. Now remember, the distance formula looks like this. x2 minus x1 squared plus y2 minus y1 squared. Alright, well, let's have this is equal to r, right, because the distance is fixed to be r. Our first point would be hk and our second point is xy, so it looks like this: x minus h squared plus y minus k squared. And if I square both sides, I end up with this. Or just flip it around. This is the equation for a circle that has a center of h comma k and a radius of r. We can now write down the equation for a circle. Right? So for example, look at this one. If the center is 0 and the radius is 5, that means the h and the k are 0 and 0 and the r is 5. I'm going to plug that into this formula and I will have the equation for a circle. It looks like this. It's going to be x minus 0 squared plus y minus 0 squared is equal to 5 squared. Or if I simplify, x minus 0 is just x, y minus 0 is just y, equals 25. X squared plus y squared is the equation for a circle centered at the origin, or at 0, 0, with a radius 5. Let's try another one. Again, we're given that we have a circle and we know its radius, so we want to find its equation. Remember, the general equation for a circle looks like this: x minus h squared plus y minus k squared is equal to r squared. Now, if you have a question of which formulas you'll need to know, make sure you contact your instructor so that they can tell you specifically how many of these formulas you have to memorize and how many you can have on the test, okay? Now in this case, h is negative 6, k is negative 1. So x minus a minus 6 squared plus y minus a minus 1 squared is equal to 7 squared. Or if I simplify that, that's x plus 6 squared plus y plus 1 squared is equal to 49. There's no need to multiply that out further. This is the equation of that circle. By the way, you should notice again that the sign inside the parentheses between the x and the 6 is a positive sign, whereas the center itself is actually on the x-axis at negative 6. So this sign right here will be the opposite of whatever the sign is of the h up here. Okay. Similarly, you can look at what's between the y and the 1 and see the same thing, that this is a positive, right, whereas this is negative. So whenever you have a center that has negatives in there, you're going to have pluses between there, and vice versa. Whenever you have pluses here, center means those values, the h and k, are negative. Now let's do one more example where we are again trying to determine the equation of the circle. But let's do it, instead of me just providing for you the center and the radius, let's look at a case where we might have just the image or picture of the circle. So let's say here's our circle right here. In fact, I'll tell you what, let's draw it in black. So that's part of the problem. Here we go. Okay, and let's just say, for instance, that we have our x-axis is here. And let's say our y-axis is here, in such a way that this is 1, 2, 3, 4, 5. Okay, and let's say the center has a high as to 1, 2, 3. and so on. So right there is the center, and this distance right here, as you can see from the picture, is 1, 2, 3, has a radius of 3. Okay, so let us determine the equation of that circle. Well, in order to find the equation of the circle, we first have to know the center. And as you can tell from the graph, I have plotted the center at over 2 and up 3. So the center is 2, 3. The radius, as you can see by counting it out in each direction, is 1, 2, 3. Right? That's from here 1, 2, 3, and to the right 1, 2, 3, down 3, up 3, so the radius is clearly 3. So using the equation we used before, which I've scrolled off the top of the screen, but remember it looks like this: x minus h squared plus y minus k squared is equal to r squared. I'm going to substitute h, k, and r in. So in this case h is 2, so we have x minus 2 squared. K is 3, so y minus 3 squared is equal to 3 squared, or x minus 2 squared plus y minus 3 squared is equal to 9. That is the equation for the circle. All points on that circle satisfy that equation. The equation for a circle is given. In this case, we have x plus 3 squared plus y minus 4 squared equals 36. We're asked to find the center and the radius of each circle, and then to graph it. Alright, so remember that the equation for a circle is x minus h squared plus y minus k squared is equal to r squared. So we've got to determine the h, the k, and the r. Now the r is always the easiest one, so I like to start there. It's the square root of the other side, right? If this is r squared, then r is the square root of 36, or 6. So we got the radius. Now what's the center? We got to find h and k. Now this, when it's in this form, is pretty easy. It's always the opposite sign. I should put that arrow in the right place. It's the opposite sign that's right here. Remember I told you before, whenever there was a plus there, that was a minus for the h. And when there's a minus sign here, it's a positive, because you have to have a minus in the original formula. When you have a plus, you have to think of it as a minus, a minus. So h is negative 3, k is 4. So your center is negative 3, 4. So if you go to your graph, you are going to go to the point negative 3, positive 4. So left 3 and up 4. Plot your center. Your radius is 6, which means you're going to count out 6 in every direction. So let's go 6 to the right. 1, 2, 3, 4, 5, 6. This point is on the circle. Let's go down 6. 1, 2, 3, 4. Down 2 more is 6. Left 6, so 1, 2, 3, 4, 5, 6 is right there. And then up 6. 1, 2, 3, 4, 5, 6 right there. Okay, and then do the best you can for drawing a circle. Fortunately, you've got a computer tool for your homework, so yours won't look nearly as bad as mine just did, but you get the idea. That's the circle. Next problem. X squared plus y squared equals 49. Aha, this one's a little bit easier. But first of all, let's do the r. I think the r is always the easiest. It's just the square root of the right-hand side. So it's 7, because the square root of 49. That's the number that when squared gives me 49. And what's the h and k here? Well, there is no h and k, right? There's no minus or plus inside, so it's 0 and 0. So to graph this, all I got to do is go to 0, 0 first. Oops. And then go 7 in each direction. So up 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7. I'm bad enough when it's on a chalkboard, but even worse when it's on this little graphing tablet. But there's your graph of the circle, and your center, of course, I didn't write it, but let's write it now. It's 0, 0. Your radius is 7. Now, what if the equation of a circle isn't in the standard form where we can pick out the h and the k. What if it's in this form right here, x squared plus y squared plus an x term plus a y term plus a constant term? How do we find the center in that case? The answer is we go back to a technique we've learned before. We use complete the square to convert this back into this. Allow me to do a couple of examples for you on how we would use complete the square in the same way that we used complete the square back in chapter 8, now to use it so we can turn our quadratic forms into perfect squares. Here's what you do. You start with putting the x's together. So you have x squared plus 4x and leave a space to complete the square. And then put your y's together. Plus y squared minus 6y, leave a space, and move your constant to the other side. Now, to complete the square, we're going to fill in what makes this into something squared. And the same thing here. We're going to fill in what makes that a perfect square. And remember, what you always do is you take 1/2 the middle term and you square it. All right? That's 1/2 of 4, which is 2, squared, which is 4. So I'm going to add 4, but I can't just add 4 to an equation because I want to. If I do it, I have to add it to both sides so I don't change the equation. So if I add 4 here, I'm going to add 4 here. Now what do I stick in here? Well, I take 1/2 of the negative 6. I'm going to square that. 1/2 of negative 6 is negative 3. Negative 3 squared is 9. So I'm going to add 9 to both sides. So now I factor what's here. Remember, that's always going to be whatever number is inside the square is the number that goes as the second term in the binomial. So it's x plus 2 quantity squared. This becomes a y minus 3 quantity squared is equal to 23 plus 4 is 27 plus 9 is 36. And look at that. We are now in the standard form. R is 6. H is negative 2. Remember, it's the opposite sign when it's inside that square. And K is positive 3. So your center is negative 2, comma 3. And you can graph that equation pretty quickly now because you have all the information you need for graphing. You're going to go to negative 2 and up 3 and go 6 in each direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6 right there. So if it asks us to graph, we've got to do this procedure. And there's my horribly graphed circle, but we're not grading on artistic ability here. Let's do one last problem just like that, just for practice sake. Put the x's together. We have x squared plus 4x, space. Put the y's together. Y squared minus 4y, space, is equal to, add 1 to both sides, put the 1 there. So half of 4 squared gives me 2 squared, which is 4. So I'm going to add 4 to both sides to complete the square for the x's. Take 1/2 of negative 4, square that, I get 1/2. Sorry, 1/2 of negative 4 is negative 2 squared, which is also going to be positive 4. So I add 4 to both sides again. When I factor, I get x plus 2 squared and a y minus 2 squared from here and from here equals 1 plus 4 is 5 plus 4 is 9. So my center is negative 2, positive 2, right? This makes the h negative 2 and the y here would be positive 2. And then the center, sorry, the radius is the square root of 9, which is 3. And we graph it the same way again. But that's how we can get from general form to standard form, by completing the square. -2, up 2, right 3, up 3, left 3, and down 3. There's the graph of that circle. And that's the end of section 10.1, where we've covered the distance formula, the midpoint formula. We used the distance formula to come up with the equation for circles, and we're able to both graph circles and find the equations for given circles.